Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to derive mean square value of a Gaussian random variable. In my previous video, we have to derive mean value of a Gaussian random variable. So we know that the second moment of a random variable is given by expectation of x square is equal integral minus infinity to infinity x square into fx of x dx. So this expectation of x square is also denoted as m suffix 2. M suffix 2 is the second moment of the random variable. So but we know that the uniform probability density function x is the random variable. So now we are Gaussian random variable. Capital X is the Gaussian random variable. Then the probability density function of the Gaussian random variable is fx of x is 1 by square root of 2 pi sigma square e power minus of x minus m whole square by 2 sigma square dx. So this exponential term is written as e power minus of x minus m by sigma whole square by 2. Let x minus m by sigma is equal to t. So take the cross multiplication and m is going to the RHS side. We have x is equal to sigma t plus m. So differentiating with respect to t, dx is equal to sigma into dt. So now here the ranges of the x are minus infinity to infinity. Here we are considering t is equal to x minus m by sigma. So in this consideration, substitute x is equal to minus infinity and x is equal plus infinity, then we get ranges of the t. So and after substituting x is equal to minus infinity and x is equal plus infinity, then the ranges of t is also minus infinity to plus infinity. So therefore, expectation of x square is equal square root of sigma square is sigma 1 by square root of 2 pi sigma integral minus infinity to infinity. So x is sigma t plus m whole square into e power minus t square by 2 dx is sigma dt. So now here on RHS side, numerator and denominator sigma is the cancel. The remaining RHS term is expectation of x square is equal 1 by square root of 2 pi integral minus infinity to infinity sigma t plus m whole square. Applying a plus b whole square expansion, sigma square t square plus m square plus 2 sigma mt into e power minus t square by 2 dt. Multiplying e power minus t square by 2 within the bracket term and applying the integration into each term, we have expectation of x square is equal sigma square by square root of 2 pi integral minus infinity to infinity t square e power minus t square by 2 dt plus m square by square root of 2 pi integral minus infinity to infinity e power minus t square by 2 dt plus 2 sigma mt by square root of 2 pi integral minus infinity to infinity t into e power minus t square by 2 dt. So which is considered as equation 1. So now here the second term is area enclosed by the Gaussian density function, that is n of 0 comma 1, and its value is equal to 1. So that is 1 by 2 pi integral minus infinity to infinity e power minus t square by 2 dt is the area enclosed by the Gaussian density function, and its value is equal to 1. And here integral minus t to minus infinity to infinity t into e power minus t square by 2 dt. This is already explained in my previous video, that is mean value of the random variable. So this is considered as function g of t, and substitute t is equal to minus t, function g of t is equal to minus g of t. So this is an odd condition. So integral minus infinity to infinity t into e power minus t square by 2 dt is an odd function. So the integral value is equal to 0. So therefore, from the equation 1, the remaining expression is expectation of x square is equal to expectation of x square is equal to sigma square by square root of 2 pi integral minus infinity to infinity t square e power minus t square by 2 dt plus m square. So separately calculate integral minus infinity to infinity t square e power minus t square by 2 dt value. So now consider 1 by square root of 2 pi integral minus infinity to infinity t square into e power minus t square by 2 dt. That one will be calculated. Consider that integration. So now here t square into e power minus t square by 2 dt is written as t into derivative of minus e power minus t square by 2. So derivative of e power minus t square by 2, differentiating this term. So differentiating this term, we get so differentiating this term, we get differentiating this term, we get so derivative of e power minus t square minus into e power minus t square by 2 into derivative of minus t square by 2 is minus 2t by 2. So 2 2 is the cancel, minus into minus plus. So t into e power minus t square by 2 dt. So this t square e power minus t square by 2 dt is written as t into derivative of minus e power minus t square by 2 dt. And after that applying UDV concept. And what is the UDV concept? UDV is equal UV minus integral V du. So now here on RHS side of this integration we consider let U is equal to T and dV is equal to minus e power minus t square by 2 dt. dV is equal to derivative of minus e power minus t square by 2. So differentiate with respect to t, du is equal to dt. And now here in this term on both sides derivation is cancelled. We get v is equal to minus e power minus t square by 2. So u is equal to t, dv is equal to this and v is equal to this. So using this expression u dv is equal uv minus integral v du and substitute u value, dv value, v value into this equation. Therefore 1 by 2 pi integral minus infinity to infinity t square e power minus t square by 2 dt is equal 1 by square root of 2 pi into uv concept. U dv is equal to u. What is the u? T into v. What is the v value? Minus e power minus t square by 2 over minus infinity to plus infinity minus integral v. V value is minus e power minus t square by 2. Before minus is there, minus into minus plus. So plus integral minus infinity to infinity e power minus t square by 2 dt. Applying these considerations into this equation and using this equation u dv concept. So therefore the RHS term of this term is 1 by square root of 2 pi integral minus infinity to infinity t square e power minus t square by 2 dt is this one. So in this first term, substitute upper value of t and lower value of t. So e power minus infinity value is 0. First term is 0 plus second term is as it is same. So therefore 1 by square root of 2 pi integral minus infinity to infinity e power minus t square by 2 dt. So this term is area enclosed by the Gaussian random variable. Area enclosed by the Gaussian random variable is always unity, that is equal to 1. So therefore substitute this consideration into this equation. Okay, 1 by square root of 2 pi integral minus infinity to infinity t square e power minus t square by 2 dt is 1. So therefore from this equation expectation of x square is equal to sigma square plus m square. Sigma square plus m square. So this is the mean square value of the Gaussian random variable.